Hey, just a video on binary for MIDI now. Hopefully you've watched my overall sort of MIDI video, where I have taken you through this table, and the idea that different bits of information has been sent with different note types, and what you may need to do is you may be asked to convert a number from binary into a number, or convert a number into binary as part of an exam question. Now, for me, this is a bit of, well, I can't actually quite see how it's useful in terms of making music. I've been making music professionally for 10 years and longer, and I've never once thought about the actual binary. But they could ask you that. So what I would say is that it can take some minutes to work out, to translate a number into binary. Some people, if it's easy for you, and some people do find it easy, some people it just makes perfect sense for, it's maths, it is completely logical, that's fine, answer the question. If it's going to take you 4 or 5 minutes for that one mark, and it will be like a one marker, take the number 93 and tell me the binary sequence, and it takes you 4 minutes, the idea that you spend those 4 minutes doing that for that one mark and then miss potential marks later on in exam as you run out of time, well, that's not a good thing. So my strong advice to you is, if you think it's going to take you a while to do the translation, move on, answer as many other questions as you can, answer the easy ones, make sure you say everything you want to say in the big question, because there's a big question at the end of the exam. I'm talking about the practical exam component 4. Make sure you get everything out of those. And then if you look at the clock and you've got 10 minutes left in your exam, or you've got longer, go back, have a stab at the binary questions, right? Stab in the dark, give it a go. If it's easy for you, by all means, sit into it. So I'm going to tell you a little bit about the binary inside MIDI, and give you 2 methods of converting binary. Well, one method for each. Converting a number to binary, or converting binary to a number. What they will ask you about is what you'll find in these 2 sections, this data 1 and data 2. The binary contained within this is slightly different, and you don't need to know. The binary inside data 1 and data 2 is always a number between 0 and 127. That's all it contains. And whilst each byte is 8 bits, we only use 7 of them to work out, to contain the actual number. The first bit in these cases is always a 0, and it uses that because by having a 0 at the beginning, the receiving instrument knows that it's dealing with one of these, a data number, and it's not dealing with this, which has a 1 at the beginning. So if you answer with 8 and the first digit is 0, fine, that's kind of ignored by the examiner. It's you won't be marked down, but you won't get a mark for putting a 0 at the beginning. They're actually only looking for 7 bits of binary data. So let's break that down. The answer is always going to be a number between 0 and 127. Right, I drew this. What made this table? There are 7 boxes here. That is because in a binary number, each digit kind of represents a number that doubles in value from the one to the right of it. So let's fill this in. So the rightmost number represents the value 1. Then the second number, reading right to left, which is again slightly not what we do in our cultures. It's like, what am I doing? I'm typing it totally wrong. I'm not paying attention. Okay, 1, 2, 4, 8. These numbers double. This sequence of numbers that is constantly double crops up over and over and over again in any sort of computing, and it's actually kind of worth knowing and memorizing this list up till, I don't know, 1024, because phones will have 512 gigabytes of space, and that's based on this doubling number: 1, 2, 4, 8, 16, 32, 64, 128, 512, and 1024. Kind of just worth knowing those numbers, in my opinion. and it's just a doubling. And 1024 is when bytes turn into kilobytes, and 1024 kilobytes is a megabyte, and 1024 megabytes is a gigabyte. And that is actually why you have less space than you think on your phone, because they round these numbers up. To say it's 6 gigabytes really is not quite. Right, anyway, so if you're given a binary number, let's do it the other way, because I think more commonly you are asked to work out the binary number for a real number. And I'll take the number 96. Let's just talk a bit more about binary before we do this. So in binary, the number 1 is this, right? Because you have 1, 1. The number 2 is this 0, 0, 0, 0, 0, 1, 2. 1, 0. Because you have 1, 2 and no ones. And therefore the number 3 is, because to make up the number 3, you have 1, 2 and 1, 1. So that's the basis we use to break down to work out what we need to know. We'll take our given number. I've written 96. I've picked it from thin air. I don't know what kind of answer it will give me, and I don't know the binary for the number 96. But the first question, you can write this down, and you can make a little table. You can even do this in your exam paper. Does 64 go into 96? If the answer is yes, write a 1. If the answer is no, write a 0 and move on to the next number. If you have answered yes, you then need to subtract 64 from the answer. This is going to work out absolutely perfectly. This isn't going to be very good, I'm sorry. So 64 minus 96 minus 64 is actually 32. Therefore, the next question is, I'll plow on with it. The next question is, does 32 fit into 32? The answer is yes, it does. At this point, we then technically have minus 32 to 30. We minus 32 from 32 and we get the answer 0, at which point 16 doesn't fit into 0, 8, 4, 2, 1, all don't fit into 0. Therefore, the binary number for 96 is a 7-bit binary, 11000000. If it was an 8-bit binary, we'd just stick a 0 at the beginning. But again, as I said earlier, that gets ignored. Let's try and do a better number, a more complicated one. It's hard to know. Let's pick 109. Picking an odd number is always a good one. So let's work out 109. Do it on the second row. Question, does 64 fit into 109? You betcha it does. And because it does, I now need to know 109 minus 64, which gives me 45. And then you answer the question, does 32 fit into 45? Yes, it does. And then you take 45 and minus 32, and you get the answer 13. So 45 minus 32 equals 13. Next question, does 16 fit into 13? No, 0. Does 8 fit into 13? Yes, 1. Then 13 minus 8. You see how I say it takes, for me, it takes a few minutes. This is how I'll do it. 13 minus 8. I say this is how I'll do it. I don't ever need to do this. Gives me the answer 5. So does 4 fit into 5? Yes. 5 minus 4. Let's say the actual mass. It's going to be 1. Does 2 fit into 1? No. Does 1 fit into 1? Yes. Therefore, the answer for 109 in binary is 110101. That's 7-bit. That's the answer you have to give. If they seem to want it in 8-bit, and they'll give you an example, feel free to shove that 0 at the beginning. So that's how you can work it out. Pick numbers from thin air and practice that if you want to. The other way that may come up is, can you convert a binary number into a binary sequence into a number? And again, I'm just going to pick this. I'm just going to invent this from thin air. Is that 7? All right, that's 7. Let's do that. Here's a binary sequence. Let's find out which. Let's find out what number that is. I'm just going to copy that back in. Please excuse my use of docs. It's just the easiest way for us all to see what's going on. Make yourself a bit of space. Right. The way I like to do this, again, make kind of this little table, draw in your reverse, doubling, halving numbers from 64 down to 1, and then write out the number in there. 1, 0, 1, 1, 0, 0, 1. Then what you need to do is add up these numbers if there's a 1 on them. So to get this, we know that is going to equal 1 plus 8 plus 16 plus 64, which is equal to, can I type this in a calculator? And it's at this point I feel obliged to say that you're not allowed to use calculators in your exam. Sorry, I'm doing this now for speed of, you don't want to watch me trying to do this in mental arithmetic forever. 89. It is, it's all possible arithmetic. It's just to ease of speed. And it's a bit of a shame that you're not allowed a calculator. So 10110001 is 89. It's quite an easy translation, this one. Let's pick another one out there. Let's start with 0110110. Is that enough numbers? Is that enough digits? Yeah, 7. Great. Again, I've just totally made this up. Do not know the answers. 1, 1, 0, 1, 1, 0. I do know it's an even number. I can tell that because the last numbers are 0. So using if there's a 1, we do maths. It's 2 plus 4 plus 16 plus 32 is the answer to what that is. And I will type this into my calculator. 2 plus 4 plus 16 plus 32 is equals 54. There we are. So there's a method of calculating binary numbers to and from, and hopefully not something you actually have to do. Right. Thanks for watching.